Good day. My name is Werner Schweppes, and I served as the project director for the Tasco-Manasman joint venture. This joint venture, called TMJV, built the Yadana Gas Pipeline as a lump-sum turnkey contract in 1997-98 for PTT in Thailand. I have already shared some interesting videos about the project. However, my old friend Zurushet Supsar Korn asked me recently to make a short video about the project, which I am now presenting. The project involved constructing 240 kilometers of 42-inch diameter pipeline to transport gas from the border with Myanmar at Ban E Tong to a large power station in Ratchaburi, now known as Ratchaburi Power Company. The Yadana pipeline also supplies gas to other pipelines and provides Thailand with 25% of its natural gas needs. Since September 1998, the pipeline has been supplying gas from Burma and has been in operation for 28 years. The pipeline includes many ancillary facilities, such as 12 block valve stations, metering installations to measure gas flow, and a control center for operating and maintaining the pipeline. It also features a 240-kilometer-long fiber optic cable, telecommunication systems, and SCADA facilities, which are used for control and data acquisition to operate and monitor the Yadana pipeline. The pipeline was laid through high mountains in an untouched forest area with steep slopes. It runs across agricultural fields, along roads and water canals, crossing 93 waterways. To accommodate changes in direction and elevation, the 42-inch pipes were bent by us using our heavy bending machines to create field bends. In particularly challenging terrain with tight curves and sharp elevation changes, we used over 80 factory-made hot bends supplied by us. Given the tight construction schedule, the project execution was extremely demanding. The construction period was further limited because 5 months of the available work time coincided with the 1997 monsoon season with the severe tropical storm Linda, which hit us as well. To mitigate some of these challenges of the monsoon season, we decided to double joint about 90% of the 42-inch pipes, consisting of 8,808 welds that were made at our newly built Ratchaburi double joint yard. We completed this work within 4 months. While transporting the 25-meter-long double-joint pipes to the construction sites was difficult, time savings in the field were achieved due to 42% less pipe handling and welding. This saved time, equalized fully all the transportation challenges that we faced on the roads. For our main pipeline construction, we used at the beginning in April 1997 2 spreads as originally planned. All the field welding was carried out using a combination of manual and mechanized welding. We welded a total of 20,700 pipe welds. All 42-inch welds were inspected by radiographic and, to some extent by ultrasonic testing. In addition, all welds were subjected to a high-pressure hydrostatic test conducted at 150 bar and above. The welds were all fusion-bounded epoxy-coated. The average pipeline laying rate into our excavated trench was 1,320 meters per day with those 2 spreads. We used our side booms for the lowering in activity, including the subsequent tie-in work of the 42-inch pipe strings. The contract established 3 important milestone dates, and we reached all milestones ahead of schedule. This achievement showed the outstanding and dominant work of the Tasco-Manasman joint venture. It is extremely important to note that our construction work was generally ahead of the project schedule. It has to be underlined that the project was built under very difficult, challenging circumstances. This included many major technical problems and subsequent project design changes that resulted in 43 change orders. Moreover, there was the late handing over of 50 kilometers of land by PTT for our pipeline work and the land for 9 of the station buildings that included the large operation and maintenance center. In addition, we had 154 landowner stoppages. The effect of the pipeline construction work stoppage and the relocation of activities was not only on the crew immediately suffering the stoppage. Each stoppage unavoidably impacted subsequent pipeline activities, since the construction of a pipeline is carried out by distinct work steps that are being executed in a logical, unchangeable sequence. All this and some other issues, such as engineering errors discussed here later, led us to file claims demanding appropriate compensation from PTT. But all these work delays weren't enough. Then, almost out of the blue, the Asian financial crisis hit Thailand in June 1997 very hard and our project as well. This financial crisis impacted everyone and led to some sluggish monthly progress payments by our client PTT. From this time on, our change order work was not paid by our client. This payment occurred 20 months later. To overcome this enormous liquidity problem, TASCO and Manasman supported the joint venture in financing the huge ongoing project costs. It's essential to note that the joint venture was responsible for supplying all permanent pipeline materials and equipment, including 7.5 kilometers of 42-inch line pipe, as well as pipeline construction and commissioning. For the SCADA system that we delivered, our subcontractor Siemens handled the engineering, supply, and installation, including a 240-kilometer-long fiber-optic cable that was installed together with the pipeline in a twin conduit. PTT was responsible for providing the epoxy-coated line pipes for the project. In addition, PTT provided the detailed engineering carried out by its consultant, Yadana Gas, OGP. Regrettably, the engineering included several design errors and deficiencies that clearly demonstrated that the construction site reconnaissance was inadequate. This was demonstrated by the 62 kilometers of missing protective concrete slabs for the gas pipeline along the roads, as well as the lack of a 1.5-meter soil cover for the pipeline. Likewise, the removal of approximately 9 kilometers of adjacent road embankments, which consisted of mountains, was not specified in the drawings, and the highway department insisted on this removal to allow for future road expansions without relocating the pipeline. Here, we removed approximately 900,000 cubic meters of earth and rock to lower the embankment to road level. For the two major river crossings of the Kwai River at Pipeline Kilometer 68 and Pipeline Kilometer 100, the horizontal drilling method in rock-saturated soil was specified by PTT and their engineering consultant, Yadana Gas OGP. However, this drilling method was not feasible. It failed after 4 drilling attempts and had to be abandoned after the work began on the river crossing at Pipeline Kilometer 68. Based on our earlier strong recommendation to our client PTT, both river crossings had to be constructed using the open-cut trench method. However, PTT and Yadana Gas, a year earlier, denied our recommendation. Finally, after the drilling failed at Pipeline Kilometer 68 on the 28th of March, 1998, PTT agreed on the 31st of March, 1998 to use the open-cut method and told us, bizarrely, it is up to us what to use. We then had to negotiate with the landowners and clear the land. At Pipeline Kilometer 100, we had to acquire 20 rai, or 32,000 square meters of land, and we paid 5 million Thai baht for this land. In parallel, we had to carry out detailed construction planning and complete the detailed engineering work that we had already begun in anticipation of a possible horizontal drilling failure, and mobilize pontoons and other specialized construction equipment, such as drilling rigs and others, in an extreme hurry. The two by us prefabricated concrete-coated swan neck siphons had the following dimensions. First, at Pipeline Kilometer 100, the siphon culvert was 140 meters long with a weight of 205 tons. Second, at crossing KP 68, the siphon culvert was 99 meters long with a weight of 145 tons. As it is obvious from these dimensions and weights, those pipe strings were large and heavy, making them difficult to transport to the trench location in the river. The underwater rock blasting was one of the major challenges, along with rock removal, to achieve the required depth of around 2.4 meters in the river trench measured from the river bottom. For the lowering in, we used a total of 8 side booms, 2 70-ton cranes, and an excavator on a pontoon. With our side booms, we managed to move the siphon culvert from the fabrication area near the West River bank, slowly and steadily. The 70-ton cranes were positioned on either side of the river, while the excavator was situated on a floating pontoon in the middle of the waterway. To keep the siphon culvert in the correct position against the river's current, we used steel cables connected to the excavator on the pontoon located in the middle of the river. Once the culvert passed the halfway mark, the second crane located on the east side of the river took over and moved the culvert forward to the excavated trench on the right-of-way river embankment. We repeated the same process at the launching bank by centering the siphon culvert into the trench. After aligning the culvert, we carefully lowered it into the trench and filled it with water. The weight of the water ensured that the culvert sat securely on the trench bottom. Both river crossings were successfully completed by us in mid to late June 1998. Nova Gas OGP has not produced any detailed construction drawings for river and road crossings. This posed a problem, for example, at the Lumpachi Canal crossing. After completion of our work, Nova Gas OGP requested an additional technical measure, the concrete coating of the already laid pipeline section. Such a concrete coating was clearly unnecessary, as we had met all the specified buoyancy requirements. Nevertheless, this artificially created problem stuck with us until the end of the project. To mitigate the effects of the monsoon weather and also to have more flexibility in working hours, as well as to increase efficiency, we, the Tasco Manasman joint venture, built a project prefabrication yard in Ratchaburi at the beginning of the project, which included a storage area and a workshop for the maintenance of construction machinery. The other main advantage was factory-like working conditions. This setup enabled us to mass-produce items for installation in the pipeline facilities. Our prefabrication yard was equipped with cutting tools, welding facilities, and all the necessary equipment for steelwork. Piping and structural prefabrication were carried out to ensure an optimal balance between ease of handling and minimizing the number of field welds. Additionally, sandblasting and painting activities were conducted in our prefabrication yard. Our construction also involved 340 road crossings, which were either open-cut or installed by means of percussive pipe driving. The largest road crossing was at Highway 4 in front of PTT's Operation and Maintenance Center, and we used the pneumatic pipe rammer for a pipe crossing length of around 100 meters. The pipe rammer pushed the pipe in one continuous run through the clay soil underneath Highway number 4, having a material cover of more than 3 meters on the top of the pipe, whereby the traffic was not disturbed by our work. The soil during the pipe ramming the earth was accurately swallowed up by the 42-inch pipe. Later the earth was pushed out like a sausage through the pipe, crossing end by using compressed air and some water. Subsequently, the crossing was connected to the pipeline, and the weld was FBE coated. The work was done by us in May 1997. In addition, there was one railway crossing with a casing pipe installation at pipeline kilometer 229. Over the course of the project, our crews had to deal with 93 water crossings that included 3 major river crossings, as discussed before. Along with the previously mentioned engineering errors, some pipeline route profile plans issued by Nova Gas OGP were flawed. Consequently, we had to reroute the 42-inch pipeline in several areas, which involved significant effort and led to additional work disruptions. Due to redirecting the pipeline 9 times at the end of the project, it was 1 kilometer longer. In the 6-kilometer-long pipeline section between the meter station located on Highway 4 and the Ratchaburi power plant, the pipeline diameter was increased from 36 to 42 inches. Here, the station piping at 2 stations, including all valves, scraper traps, and other materials had to be modified as well. This list presents 16 combined Nova Gas OGP engineering mistakes related to faults that occurred in the project and had a major negative impact on our work. We had to reschedule our construction work several times to make up for engineering design changes, the lost time due to landowner stoppages, and the unavailability of some large portion of the land needed to complete the project. Among other measures, we mobilized and deployed a third pipeline spread in November of 1997 and started immediately the construction work in the mountain section after the land was provided by PTT. To make matters worse, the pipeline right-of-way width was limited to 12 meters over a 6-kilometer-long stretch through the steep mountainous National Forest Reserve. This forest land was provided to us by PTT in March 1998 only. Our third pipeline spread, as detailed in our claims, was very costly for the Tasco Manasman joint venture. Only after the pipeline project was completed and had been in operation since the September 21, 1998, did PTT accept some parts of our legitimate claims. This was primarily done by retrospectively extending the project duration by 101 days. Delayed until July 1999, PTT paid us, which meant more than a year after the construction was completed. This was a long wait for us, considering our numerous open commitments. At the end of the 42-inch Yadana Gas Pipeline Project, the summary of major quantities was as follows. 1,023,000 cubic meters of excavation in trenches were dug out. 360,350 cubic meters of earth filling in stations were installed. 600 concrete piles were rammed into the ground. 196,000 meters of wick drains were installed in the operation and maintenance center. 21,000 numbers of mainline welds were welded, that is a total of 70 kilometers welded length. 20,000 liters of fuel consumed on average per day by our construction equipment. 62,000 meters of concrete slabs installed adjacent to highways. 105,000 cubic meters of rock blasting was done by us. 900,000 cubic meters of road embankment was removed by us. 8,500 numbers of field bent pipes and 80 factory hot bends were installed. 500,000 sandbags were permanently put in place. 340 asphalt as well as laterite road crossings were carried out by us. 3 major river crossings were executed by us. 90 waterway crossings were conducted. 1,900 people worked on the project with a 94% Thai participation. 605 pieces of heavy and other general construction equipment were employed. We, the Tasco-Manasman joint venture, built a high-quality and reliable gas pipeline system for our client, PTT.